So, we'll learn about deficiencies in IPv4. Despite all short-term solutions such as subnetting, classless addressing and NAT, address depletion is still a long-term problem in the internet. So, what is the problem? You have address depletion as the problem in long-term internet. The internet must accommodate real-time audio and video transmission. This type of transmission requires minimum delay strategies and reservation of resources which are not provided by the IPv4 designer. The internet must accommodate encryption and authentication of data for some application. No encryption or authentication is provided by IPv4. Then what is IPv6? IPv6 is something which are we doing a better version of IPv4. Internet Working Protocol version 6, also known as IPNG, Internet Working Protocol Next Generation. Internet Working Protocol Next Generation. The format and length of IP address were changed along with the packet format. ARP, RARP and IGMP were either deleted or included in the ICMPv6 protocol. Routing protocols such as RIP and OSPF were also slightly modified. So, define IPv6. IPv6 will make use of 188-bit IP address. An IPv6 address is represented as 8 groups of 4 hexadecimal digits, each group representing 16 bits, that is 2 octets. The groups are represented by colons. So you have 16 total bits and the groups are represented by colons. This is the example of a IPv6 format. Address format. IPv4 uses 32-bit address dotted decimal. IPv6 uses 128-bit address hexadecimal notation, numbers between 0 and F separated by colons. IPv4 and IPv6 are not compatible. Advantages of IPv6: larger address space, better header format, new options, support for resource allocation, support for more security. So this is the IPv6 datagram. It has a base header which is 40 bytes and a payload which is up to 535 bytes. This is the format of the base header. So version, this 4-bit field defines the version number of IP. For IPv6 the value is 6. So your version is 6. Traffic class. This 8-bit field is used to distinguish different payloads with different delivery requirements. It replaces the service class field in IPv4. Flow label. The flow label is a 20-bit field that is designed to provide special handling for a particular flow of data. We will discuss this field later. Payload length. The 2-byte payload length field defines the length of the IP datagram excluding the base header. Next, header code. Hop limit. This 8-bit hop limit field serves the same purpose as the TTL field in IPv4. Source address. The source address field is a 16-byte 128-bit internet address that identifies the original source of the datagram. Destination address. The destination address field is 16-byte, that is 128-bit internet address that usually identifies the final destination of the datagram. Flow label. A sequence of packets sent from a particular source to a particular destination that needs special handling by the routers is called a flow of packets. To a router, a flow is a sequence of packets that share the same characteristics such as traveling the same path, using the same resource, having the same kind of security. A router that supports the handling of flow labels has a flow label table. So what is this? This is IPv4 versus IPv6, a difference. Address are 32 bits, that is 4 bytes long. Address are 128 bits, 416 bytes long. Both routers and sending host fragments the packets. Routers don't fragment the packets, but the sending hosts fragment the packets up. Header includes a checksum. Header does not include a checksum. Classes of addressing are A, B, C, D, E. Classes of addressing are unicast, anycast, multicast. Configure either manually or through DHCP, that is Domain Host Configuration Protocol, does not require manual configuration. Must support a 576 byte packet size, must support 1208 byte packet size. IPv4 address uses the dot decimal notation. IPv6 address are represented in hexadecimal colon separated notation. Not suitable for mobile networks. IPv6 is better suited to mobile networks. Address space is small 232, large address space 2128. Internet Protocol Security. IPsec is mandatory in this. IPsec is optional. An IP address is made up of 4 bytes of information expressed as 4 numbers between 0 and 255 shown separated by periods. So you can have 4 bytes and the number should be between 0 to 255. In IPv6, it is represented by 8 groups of 16-bit hexadecimal values separated by colons. So this is 16-bit hexadecimal value separated by colons. So this difference of IPv4 versus IPv6 is very important.